So in this video, we'll try to discuss about the mesh API and just show you the parts what you're trying to mesh. You can select these parts. Meshed. These parts we're trying to mesh, and I will just show you the things. Um, so we'll try to delete the suppressed parts. Not this one. These are the parts only I'm trying to mesh here. This also need to have a small. I'm trying to have this also. Yes, so we try to save this and we try to mesh it and check what exactly we can do. So save this. This is entire mesh that we'll just select for our demonstration purpose only. Try to mesh now. Start. Here we selected water type geometry. So water type geometry is a geometry where there are no wall totals, no needs in geometry. All the geometry is in a good state. Go to the file layer. Downloads. So insert to here is important part of adding local sizing. So we have got these many volumes. We can just check the volumes what we got. So we try to assign face sizing. This is the part what is being highlighted. And that we will try to do some face sizing. Maybe the face sizing of add local sizing, and now the bigger element we will select. This element now we give 8 as a face sizing and local sizing. Some of this face is 8 and that face is 2. And remaining we will give as it is. And go to generic surface mesh. In the surface mesh, we will try to have a curvature norm proximity. With the curvature norm length is 36 degrees, let's select. And the proximity is equal to faces and edges. The curvature norm length is 36, like it's like dividing the circle of 360 degrees into divided by 36, it is 10 parts. So if A is any circle that is present, that would be divided into 10 parts. Now you can see this is a quarter circle, right? So this quarter circle divided by 10 by 4 parts. And the remaining is the cells per unit gap. If any cells or any edges have proximity or very close to each other, what are the number of elements that need to be formed there? So that is given as cells per gap as 1. Right, so now we try to generate surface mesh and we check how the mesh is. So the surface mesh will happen, and now after that we'll try to say if there are only fluids and walls to internal. So the fluid system between the two fluids there will be only internal region, not any wall. Yes, we want to shape topology, display geometry, and apply shape topology. The apply shape topology option. So now the topology is been shaped. You can see this surface mesh. So here the surface mesh, you can see that these are pretty fine to compare to this side because they are given a 6 or 8 sizing, and you can see this smaller one will be much more refined. You can see that this is much more refined compared to the top because we have given 2 as a surface size. So here we are getting a refined mesh compared to that mesh. And you can see, right? And now we are selecting everything as a wall. If you have inlet or outlet also, you can mention here. Update boundaries, so everything is a fluid. Update regions. So now I'm not interested to create any boundaries. If I'm interested, I need to have an inlet and outlet. So maybe now I can change these things. Revert edit. So I can create face selection. This face itself I need to select, but I am trying to select entire faces, all the six. Sorry, how many faces? One, two, three, four, five faces is select. You need to split all those faces. You can use the separate option. So now all the faces are split. Now you can try to rename this by mentioning as inlet. So this is inlet, the last inlet. Mention this as inlet. Sorry, inlet. Okay. Now I can similarly this also you need to split, and I can select this separate option to be separated the number of faces. Select this and mention as outlet. Outlet. Right? Okay. Now update the things and update the regions. Now we can add the boundary layers. So in the boundary layers we have a different method for the first layer height or aspect ratio. So aspect ratio is length to width ratio. If the length is higher value than compared to width, then the refinement will be much more. So if the aspect ratio number is huge, it's 5. So the boundary layer will have a nominal thickness. If you increase the number, boundary layer thickness will be decreased. If you go 30, the boundary layer thickness on the first layer height will be much more low. Right? So for high turbulent flows, you need to have a very less boundary layer thickness. So I'll be selecting 30. It's for the reference purpose. Add boundary layers. So after that, go to generate volume mesh. So I want to generate volume mesh. And now here you can have a different other options also of giving size field, proximity checking, boundary layer checking, and everything. But now as for I'm leaving default, so I'm trying to generate the volume mesh. So in this check, the volume mesh is being generated. So different types are belong to different objects. So that's the reason why it was belonging to different objects. So that cannot be merged into single object. You are saying. So now instead of keeping it as in the similar or the same one, maybe we can say it need not be merged as a single point. So just if you have any that sort of error, you can go from workflow to outline flow. Just go to outline flow in the mesh object in the silencer, right? In this cell zone conditions, go to auto mesh and see merge cells within the zones. Cannot merge zones of different types of different objects. So we need not merge anything. So untick this option and try to do poly, apply mesh. Probably it should happen now. So now it happened, it completed. So now we can just check for the poly mesh, select execute and this layer. So now you can see the poly structure, right? So with the boundary layers, you can see this boundary layers. As we have given this as inlet, it will not have any boundary layers, right? It is not having any boundary layers. Let's just hide this face source. Or you can have a face edges. You want to have this edge filter on. Okay. So this is one way of defining. But we have selected those bodies and those faces for our refinement purpose. And the other way, if you want any body of influence or any other thing, so we need to define it maybe separately. For example, if I want to have a body of refinement inside this, so then I need to just select this, go to sketch, select some rectangle, try to draw some rectangle, right? Now come out of this extension mode, select no much option, this one, this side, similar with the other part of it also, and just select this face, no much, this side, right? So now we've got a different body altogether. Now go file, save as movie silencer 3. So this is helpful in getting the body of influence. So only in that body we get a body of influence option, or it will be influenced and it will create put mesh. So reset this. Okay. Go to mesh, double click the mesh option, start it. So now on starting, we'll try to import that. So go to product geometry, import geometry, and go to downloads, silencer 3. Okay. So now again add local sizing. Now here we need to have a body of influence. So go to body of influence and our body. So this is our body. Select add local sizing. Right, remaining everything we'll just leave it. But this one we'll try to okay, leave that. Generate surface mesh. We can leave 36. Generate surface mesh. It's for our purpose only, so we can keep it a normal default sizes. We just want to check how the body of influence will create the region which is in and around that body getting refined. So that we need to check. So that's the purpose of simulation now or meshing now. This will be meshed. So it will take some time because we have given very coarse, also very fine refined the mesh there. It took considerable amount of time to just check how it is really getting impacted. Maybe we try to just check by describing these things, what kind of refinement we got there. So, so you can see here the refinement what we proceeded here due to the portion selected. So again, you can go for the volume mesh and everything. So this is where how you can use the body of influence option. So these are the things what we are seeing in the workflow. And anywhere when you stuck, you can go to the outline view also from workflow to outline view, and here you can do any surface improvisations or anything. Here also we can go and generate a surface mesh, right click and insert task, and have you got different other options. So to the surface mesh or you want to give any mesh refinement options in the other stuff. So this will helpful in creating mesh good quality mesh stuff. But in the next video, we'll try to discuss about outline view about how it helpful in generating the good quality mesh. Thank you.